starting with the DevSecOps metadata factory today. We all familiar with the pipeline by now, building the software, deploying it to production and measuring, as many of the previous speakers have talked about. But we still need more data. We still need to rely on data more and more. So what we did, we built like lots of metrics, and it's in various parts, whether that's your project delivering something, we got a chart for it, whether your test passed, we have like a status dashboard for it, whether your production is working correctly, even more graphs, more metrics, that's what we love. But the question then is like, are we secure? And we kind of get like some of these dashboards saying, there's been some attacks, there's some malware and so on. But overall, this is different because we don't really know whether it's up or down. And the question is, are we really secure? Like, it is a really hard thing to tell. It is a complicated thing to explain to somebody that is hard to tell about it. The more crazier the dashboards get, I'm not going to talk today about your mail servers or password leaks and so on. That will be taking too much of my time to deal into that. Today, I'm going to talk and narrow down the question, is your app secure? And it's a little bit less complicated, but it's still open-ended, and we'll see where we get in the story. My name is Patrick Dubois. I work for Sneak. Some people might know me from the DevOps days and by starting DevOps in the past. So I have a pretty long-term view of Dev and Ops collaborating together. It has mentioned before in a presentation about shifting left with security, and it is really strange for me that term kind of caught on. Yes, we were feeling responsible in production and ops or security about security, but I think many professional developers have always also been talking about security and getting it better. I see shift left as going as early as possible in the pipeline to fix issues. So that's why I start my story in the code. Because developers, they write code, and what we have, we can run some scanners like some SAS tooling, some code spell tooling, and basically they result in something like this. Some wobbly underlines in your code. You should use this, you should use that, and that's all good because that really helps drive to make your own code secure in a good way. But there's more. These days, either being lazy or not, developers, due to the pressure, or maybe it's a good thing, they go out and share dependencies. They download it from the internet. Mayman is notorious from downloading the whole internet when you install an app. But what we're actually doing, instead of looking at your own code, we're looking at all the libraries that you're using. And that term is covered by SCA, the software composition analysis. And when we look at your dependencies, we can look this up in a vulnerability database to see whether your dependencies are vulnerable or not. So whether you're installing it through a CLI, you'll get the feedback, this library, is unsecure, whether that's a nice overview. The way it works, it looks at your dependencies list. So for Node, it will look at your package.json, for Ruby at your gem file, and your POM file on Java. So because they all list your dependencies, and so we can scan it through the vulnerability database and report whether you have vulnerabilities. It's not only that they have vulnerabilities, it's also that they might have malicious intent. Even though they don't have any vulnerable code, it's not doing what it's intended. Maybe just by using the wrong name, you install something that you don't want to have in your dependencies. And again, we inform either to the CLI dashboard or in the editor while somebody's adding dependency, whether that there are vulnerabilities. And I've been talking for now around a developer, and I know this is a cloud ops, and so predominantly ops audience. But I do think over the years, like we have moved that the app is not only application code, it's the Docker file, it's the Kubernetes YAML file, and it's the Terraform configuration. That is all code, and they all have dependencies. Terraform, you download some modules. The Helm charts, you download it. Dockerfile has a base image. So we're all having this dependency kind of issue. And so it doesn't really matter whether you're doing a container or some code. Even in Kubernetes or Helm, we can do the same vulnerability scanning and report on that. And even not only on code, even on your configuration, because a lot of the cloud stuff is just configuration. It can say whether your load balancers, your ports are too wide and so on. And your Terraform, it can say that your AWS kind of security groups are too wide or stuff. So all feedback on making your code or whatever form more secure. And essentially what we're listing is all the dependencies is within that field is called the software bill of material. Basically it's a bunch of similar to your package JSON or gem file, the list of dependencies with some checksums, but it gives you the overview of whatever is inside your app. You can do that also for a container if you want to. The concept is the same. Once we kind of have this checked whether the dependencies are free of vulnerabilities, your code is free of vulnerabilities, we're checking in after the build this code as an artifact. And usually we're doing some signatures or some checksums, where that's your code that's being checksum by your committer ID, whether that's your Docker container who's signed by somebody and verified when you want to use it, or even more like when you install a Docker file, it will tell you all whether the information is more coming from that build. If you want to go fancier, you can do multi-signing in Git. The same thing exists in Notary and Docker, that you can sign with multiple people. So it's not just one person, it's multiple people saying, this is actually the build and the checksum. You might think for repositories that, a lot of people don't really verify when they download something. And of course, you use the checksum that your repository is providing. But what, for example, like in China, some sites are blocked, and you can't even always install from the official library repositories. So the checksum and verifying whether the repository itself is secure is also a step in the process. And what we're actually trying to achieve is the build chain integrity. So we got all the components, but also the environment needs to be checked. And by environment, I mean with whatever tool it's built from or in whatever environment. Because face it, your built environment are sometimes some of the least secure environments. So changing something in a compiler or a tool or whatever, that is something you need to check as well. And that brings us to like, can you trust what you build in a way? And you have to do it at several levels. And this is kind of a joke. It's kind of like the Volkswagen. Like if things report in a bad way during your test, whether it like tampers with the checksums, you kind of have to be conscious that this can also happen. And one way people are trying to solve this problem is by having the concept of reproducible builds. Like a lot of the time when we do a build on one computer and we do it then on the build server and then on another, the checksums will be different. So a lot of effort has been done, especially, for example, in Debian, whatever package is compiled or built, that it gives the same checksum. We can even take it a step further, like Bazel does, the Google build tool. Instead of only specifying the dependencies that of the packages, the tool also specifies what tools it uses, what the tool chain is that is used to build your packages as well. And fun fact, if you're doing Bitcoin and you really want to make sure, you can again put up this consensus. Let's say we have 5 machines, 5 people building the checksums, and then if they all match, then we know for certain that the checksum is the right thing. So instead of just going with the bill of materials saying these are the packages, we also want to record the steps that we are taking to build it with all the checksums of that as well. kudos to Datadog. They even built their agent in a way that like whatever gets built and signed, that you can see when it's done, how it's done, and you can follow the whole way through, even to production deploy, because that's where we actually want to end up. So we got all the artifacts delivered, we got complete traceability through the bill of material and kind of all the steps that we've taken, and now we can decide whether we're going to deploy it or not. So the whole process of building, recording all that metadata along the line and doing the tests, does that component meet my security policy to deploy it? Something like Tenable.io, you can put like the policies in place, like if it doesn't meet our requirements, just don't allow the pull of the system. And the nice thing now is, like, once a new vulnerability is detected, because it won't be maybe detected during your build and your check in and deploy the code, it can be at another time. We actually can see a new vulnerability, and we know that in production now that we have to care about. And we can even decide to do something like this example with Sysdig that would like use something like a taint node and kind of deal with a container and taint it away that it is the only one left or the pod on the certain node. So if anything happens there, then at least we got some risk mitigation in there. So what you actually see is that it isn't just the responsibility from the people who do the operations and the people who do the development. We can kind of give the feedback once thing has happened in the code. And also, obviously, as it's been mentioned before, if something happens in production through all the logging and the metrics, we can also directly feed that back to the developer that needs to handle that. The big problem is we have so many vulnerabilities once you start scanning this, and scanning is the easy part. Where do we start? The way that I tend to think about it is that what we want to reduce is not only the number, just the number of vulnerabilities. We want to make sure that we get from detecting to fixing in as fast as possible to the ideal situation that we want. That could be still with vulnerabilities. So we'll get that back to that later, but that is the point. Some would call that technical lag, whether it's in distribution between the ideal version that should be in production. It might not be latest, be aware of that, but that is kind of the lag that we are facing. So once we kind of triage this, once we kind of get on this pod, the first thing we want to do is triage, like, what is noise? And we can look at things like, what is the actual attack vector of the package, of the vulnerability? Are we using it just in our developer? Is it a DDoS, but we don't care because it's running like in a demo environment? So all these kind of things you have to reason through. And that's the hard part. The scanning is easy, but now kind of thinning, reducing the noise, almost up to a level where if it is still a bug or a vulnerability that you're considering, the list should be groomed very well. If you think you will never handle it, just remove it, because it's not a good thing to have this on your list. It will just give you like many monitoring fatigue. There will be vulnerability fatigue to kind of deal with this long list. But obviously, once we triaged that, we thought like, okay, we were not going to do this. We were still left with like some others. With those, we can look at the priorities by assessing the risk. Because face it, we all have scarce resources. What options do we have? We fix all of them. We fix the easy ones. Somewhere in the middle, that's really hard. So we really need to understand the risk. And for example, is there an exploit for it? Is there no exploit for it? So that kind of gives us a little bit more time to assess or postpone it. Because what we're trying to do sometimes in security is like wait and borrowing from the SAFE framework, the cost of delay is like, if we would not fix it and there is no exploit, we would have saved cost compared to having spent time on it. So it's a delicate balance. And it also depends on the urgency, like I mentioned before, whether there is already a fix available or an exploit available, whether we should do something about it. So you'll probably end up like this graph somewhere, tracking the highest severity and then kind of skipping the lowers, because otherwise you'll just be running around like crazy dealing with that. So we prioritize them by high and to low, and now the next step is to remediate it. So to help the developer remediate it, we want to have like a very specific, like where was the vulnerability introduced? Was it in the dependencies? Where in the Docker file was the command that introduced the package? We can even improve the speed by almost like suggesting pull requests to the developer, saying, you can just bump the version, and that's a good thing because we kind of go from there. But if you don't have tests, it's still a risk, and we can help in the risk by looking, for example, at whoever installed the update across the whole people doing the scanning, whether there is a high chance of success, whether the upgrade or the pull request is a good thing to do. We can even give you fixes that aren't in the repositories, because sometimes some dependencies go dead, or they don't have like maintainers anymore, and that becomes like really hard. We can even improve stuff. So we've kind of put a lot of the remediation and kind of fixing, but we can, obviously it's better to prevent. And sometimes code complexity is a good sign, whether bugs might happen in that space. This is a blog post by Google made very early on in 2012 or something, where they kind of give the information to manual code reviews when automation wasn't that big of a thing, so people could look at that and will be suggested this might be like a scary part because it changes a lot and you might require more attention for you to fix this stuff. There's tools coming out that enhance readability by commenting or like explaining it more like in a storyline. So that makes it like fix faster if you can read the story instead of the cryptic code. That is really helpful. And in the end, we end up with a lot more metrics that we have now the vulnerabilities. We can put them in a nice dashboard because that's what we do. But one thing, instead of only looking at how many vulnerabilities, you want to look at how fast you are fixing things. Like what's the delay? How long is it sitting from we detected it to somebody working on it, like on the triaging or something like that. This is a nice graph that I found from the people from Pivotal that talks about the vulnerability budget. So they're tracking the vulnerabilities and almost like the error budget that SRE kind of talks about. They put like this SLO and SLI to kind of put the vulnerabilities between certain bounds, so they kind of keep them in a consistent way. Because face it, we can't fix all the vulnerabilities immediately, so you will always end up in this kind of state. So it gives you again this nice graph, like how patched is your system, the bounds of 30-day target, that that's the maximum that it can sit in our pipeline to fix things. They even apply it to their Kubernetes cluster. Should we update the cluster? Should we not upgrade the cluster? Because face it, whatever platform or things that you're running on the cloud or your Kubernetes, you have to see it also like a dependency, and it may have vulnerabilities as well. So bear that in mind. But we can't, fix everything, and we can't detect everything. It is even very costly, like having to verify things all the time and having a feedback loop of detection that is so fast and fixing that will be so costly to have the team only working on this. So you have to kind of go with trust. We can get some chaos engineering to get away with the unknowns, but it still might happen that things fail. And one thing I want to have you think about is that with the whole pipeline, we're increasing our confidence. We're deploying something, we're getting better at it, we have less kind of vulnerabilities, but are we actually increasing our confidence? And one part that we haven't considered yet is the dependencies of a human in the system. John Allspaw talks about it, that when a system is working and you leave it for a certain time and no human is like watching over it, there will after some time be decay because humans have to make some decisions in that part. And so I don't want to make this talk only about the tooling and building in the pipeline and getting all the metadata flowing, because part of it, face it, eventually you will have to change your culture of trust, having people think about security, having people trust what they do, especially security. People have to let go in a way that they might start educating other people, increase their competence on those things as well. But it's a major part of dealing with these issues. So in a nutshell, to summarize now at the end, yes, we can kind of make our app secure with all the metadata. It really helps, and the workflow, we can kind of automate it. And so like in a married couple, we're still on and off, but basically we're tied together and we can get this working in a good way. So this is my talk, and if there is any questions, I'll be happy to take them.
Thank you, Patrick. It was a very nice talk and very interesting. And of course, I got a few questions for you as we have some time. Could you please describe the difference between DevSecOps and DevOps?
So yeah, DevOps, I have a very biased perspective because I've been there from day one at the first DevOps days. I think in 2009, people were already talking about security. But I do think that over time, the first thing people were worried about is, can I get the functionality going? Can I get it in front of my customers? And I found that very often security kicks in after you have a certain maturity of DevOps, meaning the pipeline, the delivery kind of process smoothed out. And then once you have more time by the automation, you can spend your time on the security. DevOps was just a label that labeled all the stories about collaboration, dev and ops together. And I think DevSecOps is doing the same thing, like people struggling how to fit security into like an organization with all the teams collaborating around it. That label is the one, that's the industry has went for, and that's where we find all the stories. So that's kind of where I see the difference and the commonalities between both.
Thanks. Yeah, as even Google mentioned in their last SRE books, no system can be reliable without being secure, and no system can be secure without being reliable.
Well, I have a tendency to say secure enough, and that's basically the reality all day, right? So yeah, that's what we have to deal with.
Can I ask you to share your camera? Yeah, thanks. So one more question before Didi comes here with the magic part. You mentioned a lot of tooling. Isn't DevSecOps more of a cultural thing?
Yeah, so I'm the first person who say like collaborate and culture. I think I mentioned it at the end of my talk. That is important. Again, there's several people, and I'm always like nuanced when people say it's culture first or it's tool first. I think tools can change your behavior if they're used in a good way and they're set up in a good way. They can change your behavior, and so they can change the culture. I don't think one can really go without the other. If I look back over time, ITIL had ticket systems, Agile had TDD, DevOps had infrastructure as code. So kind of all these kind of movements go hand in hand by some model that changed, whether that was the cloud or the way we thought about these things, and then required hand in hand with a cultural shift inside of a company. When I explain that to my kids, when they're young, they're like, oh, so that's just like in the playground, like working together. Yes, it is. So it's nothing more than that, DevOps. But yeah, obviously it helps if you have the right tools and kind of have that in place because it amplifies what you're doing culturally. So
that's true. Thanks.